So we are going to do another section on converses, right? Converse we know is just switching things around. So if a conditional is P implies Q, then the converse is Q implies P. So if we said, if it's raining, I'll bring an umbrella, the converse would bring, if I bring an umbrella, then it must be raining. And the converse isn't always true, but in this case it's going to be. So it's like the section that we did in the last chapter where we're just going to flip around our rules. So what we've learned already is that if a quadrilateral is a parallelogram, then the opposite sides are congruent, the opposite angles are congruent, the angles next to each other are supplementary, and the diagonals bisect each other. We could just say bisect. So those are the four main rules. Now we're going to learn the converses of those rules. If the opposite sides are congruent, then it's a parallelogram. If the opposite angles are congruent, then it's a parallelogram. If the consecutive angles are supplementary, then it's a parallelogram. If the diagonals bisect, then it's a parallelogram. So our homework questions are just kind of reversed. So instead, we would just look at the picture and how it's marked and just say, well, which rule is represented? So you have to look a little closely sometimes. Sometimes I like to darken the marks in. So what I notice here in number 1, well, which rule do you think it is? Sides, angles, sides, bisect, or none? You're right, opposite sides are congruent. So I'd write op sides congruent. Op sides congruent. Now, it doesn't always have to be one of the rules, so if I look at number 2, I see some markings, like here and here and here and here, but that's not saying the opposite sides are equal, and that doesn't really fit any of my other rules, so that one would be a none. Yep. How about the next one? What's the picture here? Well, let's darken it in. I see a pair of angles. I see another pair of angles. Now, this one, it's got congruent angles, so this is going to be the opposite angles are congruent. Opposite angles are congruent. The next one has angles as well, but I don't know that they're going to really work for us because I see a 70 and a 75, right? Those don't even, they're not even congruent, so that's a none. Versus here, now we've got kind of two choices. I see opposite angles congruent, so I can use that one, opposite angles congruent, or it would also be correct to say this one, consecutive angles are supplementary, because those two angles add up to 180. Consec angles sup, if I just abbreviate. If I look at number 6's markings, I see a pair of equal sides, another pair of equal, or segments I should say, another pair of equal segments. Which one does that match? Yep, diagonals bisect. Now number 7 is a little tricky. You might think it's opposite angles. Number 7 has to be consecutive angles supplementary because they didn't give us the measure of that angle, but we know we have this pair of consecutive angles supplementary and this pair of consecutive angles supplementary. You can probably tell by looking at number 8 that it's a none because it doesn't look like a parallelogram, and sure enough we've got this diagonal bisecting but not this one, so that's a none. So that's that, and then now we're going to just add on slope. And slope is something that you've done before a lot, previous math classes. And so the slopes, remember, can tell us if lines are parallel. Parallel lines have the same slopes. So you might remember how to do slope formula here, y minus y over x minus x. So if I say what's the slope of FG, I'm going to subtract the y coordinates in the numerator and subtract the x coordinates in the denominator, and 0 out of 7 is 0. So this line here has a slope of 0, which I would have known anyway because that's a horizontal line. Horizontal lines always have a slope of 0. So similarly, the slope of EH, 0 over negative 7, is also 0. So those two lines have the same slope. FG, and EH. So lines with the same slope are parallel. FG and EH are parallel. So what that's telling us is we know that those two lines are parallel. So I'm going to mark those parallel. You could probably guess that these two segments are going to turn out to be parallel too, and you're right. If I do the slope of EF, y minus y over, and I have to do it in the same order, x minus x, so 1 minus -2, so 2/3 is the slope there. The slope of HG, 4 minus 2 over 8 minus 5, is also 2/3. So those two segments have the same slope, EF and HG. Since those two segments have the same slope, those two segments are parallel. And you might say, like, why do we have to do all that? That's showing that it's a parallelogram. It's another way to show that the shape is a parallelogram. Opposite sides had the same slopes. So that's kind of what we said here. Therefore, by definition, if the two pairs of opposite sides are parallel, then we have a parallelogram. All right, we're down to the last question. This is similar to the one we had in the notes yesterday, where it's just one parallelogram with tons of stuff in it. I'm going to start with the sides because those are a little easier. So 11 is going to match 11. 9 is going to match 9. And then here on the inside, I have 3 is going to match 3, and 5 is going to match 5. And I'm going to do these first. So DC here is 11. BC is 9. O to B there is 3. How much would it be from D to B? All right, 3 plus 3, 6. AO is 5, and then 5 plus 5 is 10. So the sides are a little easier than the angles, so sometimes I start with those just to get those done. And then to do the angles, I don't want to like mess up like too much of my picture, so I'm going to erase that, and I'm going to start over with the angles. So I see a 50, I see a 20, like those two are going to add up to 70. I like to do this, people don't, but I think it's always a really helpful thing to draw the parallelogram without any other diagonals in it. And then I can see that the 70 is going to match 70, and if I subtract from 180, 110, 110. And that's going to answer a couple questions for me right off the bat. DAB is 70 degrees, ABC is 110 degrees, BCD there is 70 degrees. So those are the main three corner angles. If I go inside the shape, now I'm going to get those Z's. So I see the 20 is going to match the 20. The 50 is going to match the 50. Even here I have a Z. 60 is going to match 60. So that's going to answer some questions. DCA is 20. ACB is 50. BDC, there is 60. DBC, I don't know that one yet. I'm going to skip that one. Let me see. Oh, and ADB, those two are going to match. Oh, and then I have the AOB. So I guess I have to do that one next. So these two corner angles here, mini guys, are going to add up to 110. That's one of the hardest things that people always ask is, how do I get that little extra one? It's 110 from here minus 60, so 50 degrees. And that's going to go for DBC and also up here for ADB, 50 degrees. And then I put a star by AOB. AOB is right here in the middle. One thing that always helps in these messy pictures is to try and find triangles, because we know that triangles always add up to 180. So I have a 60 and a 20, which is 80, and that's going to make that guy 100. And I know that's tough, and I know that's a lot of things on one picture. It helps, like I said, to draw it blank like that. But really, that's as hard as it gets. So you'll see a real similar question on the homework. So this is going backwards, showing a quadrilateral is a parallelogram.